For Ferris, safety is of the utmost importance. It's embedded in our culture, it's embedded in everything that we do. It's really at the forefront of all of our operations. For the most part, people have natural gas in their homes and don't even really realize it. We operate natural gas all across North America. Any product can be either safe or unsafe. It's really how we treat and respect those products. So from our aspect, we put a lot of controls in place to make sure that that product is safe.
Liquefied natural gas is basically natural gas that we use in our homes for heating and cooking. We've been using it for decades in very safe, controlled manners. As long as there's a pipeline, we're able to use that commodity as a utility and as a resource. When we don't have a pipeline, it gets difficult to use. So what we do is we actually will liquefy the natural gas, which reduces its volume by about 600 times. If this was natural gas in its vapor state, I would have to have 600 of these on the table to accommodate one liquid version of the tank. So how do we liquefy natural gas? We take out all the unwanted constituents, we run it through a refrigeration process, and we chill it to the point of approximately minus 162 degrees Celsius. So when we're talking about cold temperatures like that, a minus 30, minus 40 Celsius day is actually heat, it's actually warmth for liquefied natural gas. So how do we keep it in a liquid state? We use cryogenic dewars such as this. These are basically double-walled containers, very similar to a thermos, which we've all used throughout our lives in school and keep the hot chocolate hot, the coffee hot. When we talk about transport tanks that are transporting the commodity, they're all double-walled tanks. I'll give you probably your first time view of liquefied natural gas. And as we go through and start pouring the LNG into some of the beakers and things, we'll talk about what the product's doing so that people get a better understanding of what's happening with the product. You can see it boiling as I'm pouring it. And the noise that you hear is rapid phase transition. It sounds like water boiling in a pan. What that is it's the liquid converting itself back into a gas. So actually what you're seeing now is you're seeing liquefied natural gas. You're seeing natural gas that is running into homes, that's running in pipelines throughout jurisdictions all over the province, all over the country, and it'll continue boiling to the point where it cannot draw that heat anymore. It'll stabilize itself, it'll settle itself down. What I'm going to show you next is how it reacts if we spill it. So we can see it kind of bouncing around. It's like water in a hot frying pan. I'm sure a lot of folks have seen that. Again, the boiling you're hearing is it's finding a hot spot. And as I move the liquid around, it gets a little harder to get it to convert back into a gas because of all the heat that it drew from the pan. So if you actually put your hand on the pan, this pan is now extremely, extremely cold. It took every bit of heat from the pan to convert the liquid back into a gas. Once it converts itself back into a gas, it's virtually gone and will have absolutely nothing left but a very, very cold surface. What happens when we spill it on soil? And so what I've got here is I've just got some generic light soil. So again, you're seeing a lot of vapor, you're seeing condensation of, again, a very cold gas, condensing water molecules in the air, creating the big fog. All I've got is I've just got really, really cold soil, and as you can see, the consistency is still very loose. There's no water. When I compress it, again, there's really nothing left. There's no liquid left in here at all. So again, we've got just basically a very nice potting soil. It's exactly the same material that we had spilled the LNG on, and again there's no contamination, no evidence that LNG was spilled on it. However, we take a hydrocarbon fuel such as, again, diesel, as you can see, as compared to LNG, the LNG boiled off, whereas your diesel still remains in the soil. And it's totally saturated, it's wet, you can see it's getting stuck on my gloves. It's never going to go away, and it's now soil that we have to remediate. The next one is water. I don't use goldfish like you'll see in some demonstrations. I don't want anybody or any other living organism to be compromised or even threatened when I do these demonstrations. So again, it's just basically bottled water. So there's the boiling that we saw in the other two situations. And what you have left is ice. So we took basically bottled water that was not frozen, not clear, or close to freezing temperature, and because the LNG drew the heat from the water, it converted it into an ice. So from another environmental perspective, what's the condition of the water? Yes, it's great that it converted it to ice, and that's a marvelous thing. But what impact is it going to have potentially to aquatic life? Again, I try and preserve the goldfish, so I'll just demonstrate on myself. Absolutely no contamination to that water at all. So again, it'll float on top, it'll convert itself back into a gas. The end result is you may have ice on the surface of the water, but there's no contamination of the soil, no mixture into the lower levels of the water, and no hazard to aquatic marine life in the spill zone. We're now going to spill some diesel just to show a comparative of what happens when there's a diesel or a gasoline spill that occurs. So now what you can see is that the hydrocarbon, the diesel's floating on top, but it is not dissipating. And if this was flowing water, this diesel would go downstream, contaminating other areas. So in comparison to LNG, which dissipates itself, it converts itself to gas and is gone, diesel or gasoline or oil or any other hydrocarbon will stay floating on top of that water. Now, would I drink that? Obviously not. So as I said, LNG expands 600 times to gas. And this is what it kind of looks like. There's your boil rate. That's telling me how fast it's going to boil off. The gas within this balloon now is the gas that we have in our homes. This is the gas that is a big part of our daily lives. So that's your expansion. What I want to show you is now as we apply a cryogenic liquid back to this gas, we will actually see recondensation of the gas back into a liquid in this balloon. So we didn't get it back to the original size, but we got it down quite a ways. And there's a little bit of LNG in the bottom. As it absorbs heat, it's going to expand itself back to its original size. What I'm hoping to demonstrate in this next little tidbit here is the flammability of natural gas in a balloon. And everybody's going to have to excuse me. I always ask my audience to be my eyes for me, to tell me what color the flame is. Okay, so I closed my eyes. Did anybody see what color the flame was? There was no flame, and the reason there was no flame is it was pure natural gas in that balloon, that we didn't have the right mixture of air to gas to be able to have a flame or to have a fire exist. What I want to demonstrate here is that it doesn't explode. It'll poof, but then it'll burn very, very lazily. So what you're seeing is a very lazy flame. You're seeing a very orange flame. You're seeing absolutely no smoke. You're getting absolute 100% combustion. And again, as the liquid's grabbing some of the heat from the flame, it converts itself into a gas and it's gone. The interesting thing about this is if you feel the bottom of the pan is freezing cold, you can see the frost. And again, absolutely no residue material left, no carbon buildup, no nothing. You just get frost in the bottom of your pan or the bottom of the surface that was on fire. We've got a little bit of diesel in the pan, similar to what we did with the LNG, and we're going to attempt to ignite the diesel. As compared to the LNG, the thermal radiation, the heat coming off of it is not as warm as the LNG. As you can see, the smoke, the black smoke coming off the diesel as compared to absolutely no smoke from the natural gas.
I think really it's very important for people to just really understand what a product is, and that's really the goal of this, is to help educate people. Because it's so new to a lot of people, really LNG's been in the marketplace for a lot of years. It's been operating safely in their neighborhoods for, going on 40 or 50 years. They haven't even known that it existed. It's just really hit the mainstream now. So really that's what we're trying to accomplish here is to get the message out that it is a safe product if it's utilized properly. Anything can be safe if you respect it and put the proper controls in place.